Assalamu alaikum. Welcome back. In any network performance study, it's important that we choose the right performance metric and the right performance evaluation technique. But the question is, how do we actually know which technique is best for our goal and which performance metric should we study? We address this question in today's session. The first thing I want to talk about is performance evaluation techniques. The various performance evaluation techniques that exist and the various trade-offs between them and which technique is applicable when. So let us start then. Before actually giving you the trade-offs between these techniques, it's important that we understand what performance evaluation techniques exist. And broadly speaking, there are just three performance evaluation techniques. These are, firstly, analytical modeling, secondly, simulation, and third, measurement. Actually, we can divide all network performance evaluation techniques into these three broad areas. So the first thing is analytical modeling, and I start by discussing this. So imagine that we want to analyze the performance of a router, and we have some packets coming in and queuing up before this router for service. The router can service only one packet at any given time. So what we can do is we can abstract this router and these packets into a queuing model. So we must understand firstly what abstraction means. Abstraction simply means simplification. Yani ke, okay, this is a router, this may be a router of a particular company, it may have some hardware specifications and software specifications, but if we think of it in a very simple manner, it's just a queue in which some customers are coming and they are provided service by a server. When a server is providing service to any customer, the other customers which arrive at that time are going to queue for service. So if we take this abstraction and apply it to the problem of a router and the packets coming in, we can answer some very interesting questions. For example, we can answer the average time a packet waits for service. We can also answer the average queue length, or we can answer the probability of waiting time being more than a certain threshold. But we must remember, because analytical modeling represents a practical system using some mathematical formulas and mathematical relationships, maybe a set of equations, it is not going to be a very accurate depiction of reality. So we must live with this. And we must understand that the analytical model is going to make a lot of approximation. So it's not going to give you very accurate results, but it can give you initial results. It can give you insight into how things would work, even without the pains of actual measurements or maybe the burden of doing an actual, simulation programming exercise. So some approximations that we do with analytical modeling may be that you consider the packets to be arriving independently. That's more of a mathematical convenience rather than true depiction of reality, because in packet switch networks, it would be known to you that packets come in a bursty manner, which is packets would come together, and when they come, they would come in a bunch. And there would maybe be a very large time, idle time, in which no packets are coming. So it's not a very realistic assumption, but we make this to make our queuing models more tractable, where tractable means that we can handle it more simply. Another approximation that we would do is, instead of thinking of the actual pattern of incoming packets, we would abstract it with mathematical distribution. So we would actually be studying mathematical distributions. It's just an abstraction. Instead of dealing with actual data, हम कहते हैं the data has this characteristic, उसको हमने model कर लिया. एक traffic source हम खुद बना लेंगे, which will be creating data according to some well-known distribution. And then we actually perform our analysis on the basis of this approximation. So it's important to realize analytical modeling is quick, but it is also approximate. So if our goal is to find quick approximate answers, analytical modeling would be very appropriate. The next technique is simulation modeling. And in simulation modeling, we replace our considered problem of a router with packets coming in with maybe a queuing model programmed in a computer. We would build what is known as a computational model. And this computational model can be made arbitrarily complex. So if you want to add more details, you can program your computational model so. And if you want to make it simple, you can also do it so. So in simulation, we can actually model anything. So if we cannot use any technique, the most general technique is simulation, because we can model any technique, any particular concrete application in this. The only drawback is that it's a programming assignment, and like all software engineering tasks, it is going to be, firstly, it is going to be, it will be having certain bugs, and it will also be taking a lot of time. So for example, usually good simulations take months, or जो analytical modeling है, it can be done in a day, and it does not require any computers. It simply requires, maybe knowing certain relationships and a paper and a pen and just the analyst. So this is the trade-off. But analytical modeling is only applicable for very simple systems. For more complex systems, you would need to build a more detailed model, because an approximate model would not capture the essence of this complex model. So to summarize, simulation would be applicable more generally, and it can be programmed to have any arbitrary level of details. The last network performance evaluation technique is measurement. And in measurement, we actually measure the performance of the system that we are studying. So it may be, for example, by instrumenting the device. But one problem with measurement is that measurement can only be done when a prototype of the system exists or the actual system exists. What happens when we are actually thinking of designing a system? Measurements can obviously not be done in such a stage, and we are left to only the options of analytical modeling and simulation modeling. But still, generally, it is believed that measurements are the most accurate depiction of reality, but this is usually the case among lay people. But among the experts, we know that the experts know that even actual measurements, they have errors, and if it is a systematic error, we would have to validate the results we're getting from a measurement by some other technique. So for example, we'd be seeing the methods of validating the results of any technique. It's not enough that we just analyze a system with one technique, because all these techniques have their strengths and their weaknesses. Analytical modeling is very approximate, so you can just not depend on this. You need to have other techniques backing up the conclusions of analytical modeling. Simulation modeling, for example, takes a very long time, and the case of measurement, you may have errors. So we need to validate the conclusions we're drawing. So this is another thing that we're going to study in just a little time. So one thing that we need to understand is, while analytical modeling very easily gives us steady state average case statistics, that is not the case in simulations and measurements. Measurements में आपको, for example, बहुत सारी चीजें measure करनी पड़ेंगी before you can make meaningful statistical inferences. Similarly, for simulations, getting to the steady state is actually going to be a time-consuming task. So you cannot just simply run small simulations and draw conclusions from this. Simulation, by definition, is only going to do individual runs, और उन individual runs से आपने खुद generalize करना है, whereas analytical modeling already gives you general results. So I'm going to recap all of this discussion and tabulate the differences between these three techniques. So let us start this discussion on the comparison between the three different techniques: analytical modeling, simulation modeling, and measurements. So if we consider the stage at which these techniques are applicable, then analytical modeling is applicable at any stage. For example, you don't need to have prototype or an existing system. You may do it before the system is built. You may even do it while the system is there. But measurement actually requires the system to be present or the prototype to be present. Simulation can also be done when the prototype does not exist. So for questions of design, when you're building a new system, the only choice that you have is, the only two choices that you have are analytical modeling and simulation. And measurements is not really an option because you don't have the system. The next metric on which we're going to compare these three techniques is time required. So the time required is least for analytical modeling. You can do it in a matter of day. So if you're using computer, you can do it very quickly. The question is just modeling the system you're considering. जब उसका आपने मॉडल बना लिए, if a closed form solution exists, वो आप फौरन कर सकते हैं. Simulation में अक्सर काफ़ी टाइम लगता है. It may actually take you even months. If your system is complex, then it is going to be a long and a lengthy task. Measurement में it really depends, because if your system supports instrumentation and gathering of data, it may not take you a very long time. But if your network performance evaluation study involves also instrumenting the system, then it may take a very lengthy time. So it really depends. The best technique, if we only consider the time, is analytical modeling. The next metric is the tool that we require. And again, in this case, analytical modeling comes up best because it does not have any extensive requirement. It just requires analysts and their time. So there is no need of having, hi-fi computers or even instrumentation or anything of that sort. Simulation agar aapne karni ho, so you need to have, computer programming languages, you need to have computer programmers, you need to have computers, and you need to have a lot of time, because simulations, because they are, inherently more complex than analytical models, so they tend to take time during programming. Lastly, measurement की हम जब बात करें तो measurement में हमें instrumentation करनी पड़ती है device की. Many of these systems actually provide support. They already give you certain measurements. But if you need to have explicit measurements, then you may need to add a specific instrument to your device to capture the measurement that you want to make. So this would then be more disruptive than analytical modeling. So even in this metric, analytical modeling is best because it requires the least resources. The next metric is accuracy. In this, analytical modeling is not very good because obviously वो काफ़ी approximation कर रहा है. It is representing a real system by just mathematical abstractions. So it's not going to capture all the nuances of the real system. Simulations चूँकि ज़्यादा complex होते हैं, वो ज़्यादा accurate modeling कर सकते हैं और उनके results भी ज़्यादा accurate होंगे. Measurement, again, it depends then. Because if your system is such that you have accurate measurements from it, your accuracy can be quite good. But if your measurements are not very accurate, then the accuracy of your conclusions would not be very good as well. So we would say that the accuracy of measurements is maybe, it is variable, but the accuracy of simulations is best, and you can make it as good as you want. So if you want to make it very good, you can spend years on it, but it is not advisable because all the network performance evaluation studies, they have a time plan. So maybe you want to analyze something in 3 months, and if you extend the evaluation beyond that, the goals of your network performance evaluation would be affected. So in many cases, it's a trade-off. You have to see how detailed your model should be. You don't want to make it too complex because it is going to take more time, it is going to take more resources, and even if it is very accurate, it is still not going to be completely realistic. So we have to find the balance. The next metric I want to talk about is which technique can you use to make trade-off evaluations. या अगर हमने comparisons करने okay what will happen if I change this, इस केस में again analytical modeling is best, क्योंकि जिस जोन से ये क्वेश्चंस आंसर कर सकता है उसमें ये जनरल आपको स्टेटिस्टिक्स देता है, तो इस वजह से you already have steady state solutions available in a very short time. But in simulations, the comparisons are moderately hard because you need to run many simulation instances. उनको आप काफ़ी लेंथ के लिए चलाएंगे so that any transient behavior, क्योंकि जब हम simulation start करते हैं उसके शुरू में behavior जो होता है it may not be representative of the long term behavior. So you have to run this simulation for a long time, and it really depends on the task that you're doing. So it again comes into the art of network performance evaluation, deciding how long you want to run your simulations. Or measurements, maybe again it is difficult because answering what if questions with measurements is actually going to take a lot of time. The next metric I want to talk about is cost. Cost में भी analytical modeling में बहुत minimal cost है. In fact, कोई ज़्यादा cost नहीं है except the time of the analyst. In simulation, you have obvious costs. You need to have a computer. You need to have computer programmers. You need to have computer programs for an extended time. So you have to arrange for these resources. Measurements, maybe the cost is high because often you have to instrument the system, and because of that, the cost may be very high. The salability of results. इसका मतलब ये है कि if you actually have results from these techniques and you take it to your management, आपकी मैनेजमेंट सबसे ज़्यादा किसको बिलीव करेगी, तो उसमें देखा यह गया है कि अक्सर मैनेजमेंट बिलीव्स मेजरमेंट द मोस्ट बिकॉज दे थिंक दिस इज द मोस्ट एक्यूरेट ऑफ द रिजल्ट्स दैट वी कैन हैव. But we will see actually that this is actually not always the case because many measurements may not be very accurate. If your instrumentation device does not give you accurate measurements, or it has systematic errors, your conclusions may not be very sound. So it really depends. But the scenario is like this, that the salability of measurements amongst the management is the most. Analytical modeling की सबसे कम है. उसकी वजह ये है कि people generally don't believe that a real complex system can be represented by mathematical abstractions. But it is often seen that these mathematical abstractions can give you, good early approximate answers. Lastly, I want to talk about applicability. So we see that in all scenarios, practically all scenarios, we can apply simulation. Because simulation में आपके पास control है, आप अपना model कितना ज़्यादा detailed बनाना चाहते हैं. लेकिन analytical model हर जगह अप्लाई नहीं कर सकते because it is applicable to simple systems, but when you have a complex system जिसके अंदर workload कि किस तरह डेटा आ रहा है, वो इतना आसान आप उसको डिस्क्राइब नहीं कर सकते using mathematical abstractions like exponential distribution. ये हम इसको कोर्स में पढ़ेंगे. These are very simple distributions, but actual traffic is often not following such distributions. For example, the time a router takes to process a packet is not exponentially distributed typically, and the inter-arrival time is also not exponentially distributed. पर आमतौर पे हम ये assumptions लेते हैं. पर if your system is such for which these assumptions do not hold at all, then our analytical modeling is not applicable. Measurements भी जो है वो सिर्फ कुछ cases में हम apply कर सकते हैं. Specifically, measurements are not applicable when you are in the design phase and you don't have prototype existing or a real system existing. So now I'll be talking of rules of validation, that you have the result of one technique. How do we validate it? Validate का मतलब ये है कि आपके पास जब results आए हैं तो आपको कितना confidence है उनमें, और confidence आपका तब बढ़ेगा जब आप उनको match कर सकते हैं against other techniques. और अगर वो टेक्निक्स भी सिमिलर रिजल्ट्स दे रहे हैं तो यू वुड हैव मोर कॉन्फिडेंस. In fact, one of the theme of this discussion now is that you should not be depending on just one technique. So you remember the example I gave about the person with one watch and the person with two watches? In network performance evaluation study, it's better to have 2 or more watches, because if we only depend on one watch, it may actually be out of sync. इसी तरह network performance evaluation technique जो भी हम इस्तेमाल कर रहे हो, it may be analytical modeling, it may be simulation, or it may be measurement. Any of these techniques is not completely accurate, and in fact your assumptions may be far out of place. So you need to validate. अगर आप analytical modeling कर रहे हैं तो उसको validate करें against simulation या measurement. अगर आप simulation modeling कर रहे हैं तब भी आपको validate करने की ज़रूरत है with at least either analysis or measurement. Measurement जब आप कर रहे हो तब भी आपको कंपेयर करने की ज़रूरत है, और ये अक्सर लोगों को हैरान कर देता है कि because when we are doing measurement on an actual system, why do we need to validate? The reason is all measurements are error prone, and all measurements except maybe the example of counting have inherent error. कोई भी आप measurement ले लें, it has inherent error. अब how do we know that this measurement has a large error or a small error? It may be your instrumentation is systematically flawed. तो उसमें you must match the results of your measurements against either analytical modeling or simulation modeling. इसके अलावा एक और हल भी है. This is actually done practically a lot, in which you don't actually validate against other options, क्योंकि in an ideal sense, okay, we want this. In fact, अगर आप validate करेंगे against other techniques, you're going to have more confident results. But if you cannot do that, what you can do is you can match your results with the opinion of subject matter expert. तो अगर उनमें भी sync है, यानी अगर जो subject matter expert की intuition predict कर रही है और जो आपके result आ रहे हैं, अगर उनके अंदर synchronization है, you can also be somewhat more confident that your results are valid. So let me then recap all the discussion on NPE techniques that we've done. We've seen that there are 3 main technique types: analytical modeling, simulation, and measurement. We've seen that no technique works best in all scenarios. So it really depends which technique is best for your goals. So if you want your results very soon, you must check if your system can have an analytical modeling solution, because if you can have an analytical modeling solution, it can be done very quickly. But if, for example, you require very accurate results, then maybe analytical modeling solution is not the best option. Maybe you need to do simulation. So after having discussed the various trade-offs, it is hoped that you would be in a better position to understand these techniques and when to use these techniques. So let us now start a discussion on network performance evaluation metrics. And we'd be seeing that there are only 3 fundamental network performance evaluation metrics, or types of network performance evaluation metrics, and all other metrics are actually derived from these. So let us talk about these basic types of network performance evaluation metrics. The first fundamental type is the metric of time, or time duration between 2 events. So examples of such metrics belonging to this type would be, for example, the round trip time. So we know that, for example, round trip time इस तरह होता है कि आप packet send करते हैं, the time it takes for the acknowledgement to come back, this is known as the round trip time. The time it takes for the packet to go to the other end and come back. So this is an example of a metric which belongs to the type of metric of time duration. इसके अलावा बहुत सारे metrics ऐसे हैं जो कि time duration को measure करते हैं. For example, response time, mean time to failure, mean time between failures. ये जो आखिरी 2 metrics मैंने बताए failures related, these are reliability metrics, and it measures the time between failures. इसके अलावा एक और fundamental type of network performance evaluation जो metric होता है, it deals with numbers. Numbers का मानी यहाँ ये है कि either counts of some event happening या the size of certain parameter. So this is another fundamental type of metric. Let me give you some examples. An example could be total number of IO requests, or the number of error, or the number of failures. These are all counts of something. The third kind of fundamental performance metric type would be rate-based metric, in which you're normalizing a count, for example, against unit time. So an example of this would be throughput in bits per second or packets per second or even jobs per second. और बाकी जितने भी metrics हम देखेंगे कि they can actually be formed from these fundamental metrics. So for example, you may take a ratio of a number-based metric and a time-based metric to form a new metric. तो सारे performance metrics जो हैं इन्हीं मतलब broad type से derive होते हैं. So typically they measure either time or they count something or they take the size of certain parameter, या वो किसी चीज को normalize करते हैं against unit time और उस पर measure करते हैं. So I hope you are clear कि metric का मतलब क्या है. Metric is just a standard measure जिसके ऊपर base करते हैं आप performance को. तो उसके हिसाब से आप देखते हैं कि okay, performance is good or bad. So how do we determine the set of metrics that are needed for a particular network performance evaluation study? That depends on the kind of service being offered by that system. तो इसको हम ऐसे analyze कर सकते हैं. Let's see this animation to clarify and illustrate this concept, that how do we select performance metrics that capture the performance of the system that we are interested in. Initially, we think of all the services that system offers. उसके बाद एक एक सर्विस के लिए हम देखते हैं कि okay, if we send a request for that service, what can happen? Two things can happen. Either it will be done or it will not be done. So let's say if your request is being processed, what can happen then? It can be done correctly or it may be done incorrectly. तो जब आपकी request perform हो रही हो, उसके appropriate processing हो रही हो, तो फिर कौन से relevant metrics हैं? उन metrics को हम speed metrics कहते हैं और उनकी example है time metric, जिसमें for example आप response को measure कर रहे हैं कि request भेजी, उसका reply कितनी देर में आया, request भेजी, appropriate processing कितनी देर में हुई. So this is the time metric. Another example is the rate metric. इसमें आप किसी events के count को normalize करते हैं against unit time. Again, this is measuring how well your system is operating. This is another kind of a speed metric. और speed metric की एक और किस्म होती है resource metric. And this resource metric is a ratio. जिस तरह utilization जो है, it's a ratio between two times typically. Utilization होती है कि आपका system कितनी देर busy रह रहा है. तो ये ratio होगा of the busy time divided by the total time. So these are all examples of speed metrics, that your system is performing appropriately for a task, but how speedily is it processing? The other thing that can happen is that the system will do the job, but it will do it incorrectly. For example, it may send the packet forward, but it may cause a bit error in it. So your frame, for example, might be corrupted. तो इस किस्म की जो एरर सिचुएशन है उसको हम कैसे मेजर कर सकते हैं? तो उसके लिए हम इस्तेमाल करते हैं metrics that are known as reliability metrics. So here we are measuring how reliable is the service of the system that we are considering. तो उसमें एक एग्जांपल हो सकता है कि what is the probability of error? For example, is the error very rare? Maybe it is occurring after 1 million bytes. Or is it so frequent that it is happening very frequently? इसके अलावा और जो हम चीज़ें measure कर सकते हैं उसके अंदर एक चीज़ included है mean time between errors. So for example, इसमें हमने पहले भी देखा mean time between failures and mean time to failure. ये दोनों आज के लेक्चर में हम देखेंगे कि इसका क्या मतलब है. These are both reliability metrics और इससे हम measure करते हैं कि how reliable the service of the system is. उसके अलावा if there are certain things a system will not do, so those things can be measured by availability metrics. An example of which would be duration of downtime. तो downtime का मतलब है that time during which your system is not available for service. So obviously this is something which is not desirable. तो इसको हम measure करेंगे और फिर हम देखेंगे कि इसको हम कैसे minimize कर सकते हैं. So if you see all of these metrics now, you would see that certain metrics are, metrics that we would like to maximize. Example would be the throughput. Obviously, हम चाहते हैं कि हम ज़्यादा bits per second transmit करें, हम ज़्यादा packets per second transmit करें. But there are other things that we would like to minimize. Example would be the response time. हम चाहेंगे कि हम जब request भेजें, उसका reply हमें फ़ौरन मिल जाए. Other things in which it's not quite clear. For example, utilization में, is it better to maximize or minimize? So let us see this then in some more detail. कि utility of metrics को हम कैसे define करते हैं. So in fact, there are three kinds of metrics if we think of the utility of metrics. Some metrics are best when they have a small value. तो इनको हम कहते हैं lower is better metrics, या इनको हमने LB metrics यहाँ लिखा हुआ है. इस केस में अगर metric की value कम है तो आप observe कर सकते हैं ग्राफ में कि उसकी utility ज़्यादा है, लेकिन जब metric की value बढ़ती है उसकी utility भी कम हो जाती है. So these are lower is better metrics. And you have the other kind which is higher is better metrics. उसमें you would like the metric value to be as high as possible. तो इसमें हमारा गोल होगा कि metric को हमने maximize करना है. An example of a lower is better metric is response time, whereas an example of a higher is better metric is throughput or availability. और कुछ cases में we would like to have nominal values of the metric, यानी ना बहुत ज़्यादा और ना बहुत low. An example of such a metric is utilization. People who are aware of network operation, they would know that response time is actually a function of utilization of the network. जब network lightly utilized होता है तो you get very good response time. But as the utilization of the network increases, the response time actually goes down. So we would like to have a balance between these two scenarios. हम ये भी नहीं चाहते कि utilization बहुत कम हो, because that is going to be counterproductive to the owners and maintainers of this network, because they would like to have as much traffic as is possible, because they can attract customers, they can make money in business. But also if the utilization goes beyond a certain point, जो user experience है वो इतना ख़राब हो जाएगा कि in fact the same thing is going to affect the business of the network operators. So we would like utilization to be at a nominal state, and that is exactly what is shown here, that we see metric on the horizontal axis and utility on the vertical axis. So you would observe that lower and higher values are not desirable, but a moderate value is desirable. And we can see this relationship in some more detail on this slide. We see that as the load increases, initially the throughput increases, and the response time, while it increases, it is not increasing in an alarming fashion. But we reach a certain point which is known as the knee point. उस केस में आप देखेंगे कि जो increase in throughput है वो या तो flat हो जाएगी या तो बहुत ज़्यादा minimal हो जाएगी. So in this case you can observe that there is a marked decrease. उससे पहले increase काफ़ी ज़्यादा हो रही थी, लेकिन when we reach the knee capacity तो throughput की increase काफ़ी markedly कम हो गई है उसकी increase. At the same time आप response time को अगर measure करें और उसको observe करें तो आप देखेंगे कि as we go past the knee capacity, response time भी अब काफ़ी तेज़ी से बढ़ रहा है. And we reach a certain point known as the usable capacity. उस पे आप देखेंगे कि response time इतना बढ़ गया है कि it's counterproductive for the network service providers, and the user experience is going to be so bad that we are actually going to set a threshold, and we say that if this is the pre-specified response time limit और इससे ज़्यादा हम नहीं चाहते कि response time बढ़े, accordingly हम चाहेंगे कि जो load है वो भी उससे कम रहे. So we see then कि क्या relationship है throughput और response time का. तो अब हम डिस्कस करेंगे फर्दर कि जो फंडामेंटल टाइप्स ऑफ मैट्रिक्स हमने स्टडी किए हैं उनकी मज़ीद कुछ हम मिसालें देखेंगे. So in all time-based metrics, what we're considering is the time elapsed between two events. So all time-based metrics follow this definition. So a first example would be response time. And I want to show you that we can actually define the same metric having the same name in different ways. So for example, response time का क्या मतलब है? In fact, people can have different definitions of the same. क्योंकि देखें, अगर हम एक request भेजते हैं, so this request is not going to go instantaneously. I'm going to start sending the request and I'm going to complete sending the request. उसके बाद this request reaches the destination and it is going to start processing this request. उसके बाद it will start sending the reply and then it will complete sending the reply. So what is the response time? It's actually quite tricky because people often define response time in different ways. तो जब आप इस किस्म के metrics इस्तेमाल कर रहे हो, it's important that you explicitly state कि आप क्या उससे mean कर रहे हैं. Response time can actually be the time after the user request has ended and the time from there till the system starting a response, or it may be the time after you have sent a request and the time till you have received the complete response. So we have two different variants of response time. The moral of this story and the gist of all this discussion is that it's important that you make explicit your definition, because you're going to have many different variants of the same name. So we should not actually be causing confusion, and if there is a consensus that this thing is defined in this way, we should follow that standard. इसके अलावा टाइम मेट्रिक्स और भी इसकी किस्में हैं. फॉर एग्जाम्पल, अवेलेबिलिटी को आपने मेजर करना हो तो you can do it in terms of uptime and downtime, and both of these are time metrics because they are measuring time. Uptime का मतलब है कि since the last downtime, how long has the system been up and available for service, and downtime is obviously when the system is not available. तो इससे हम देखेंगे कि ये अप टाइम और डाउन टाइम जो है, इससे हम अवेलेबिलिटी को क्वांटिफाई कर सकते हैं. इसके अलावा कुछ और टाइम बेस्ड मेट्रिक्स जो हैं, उनसे हम रिलायबिलिटी को क्वांटिफाई कर सकते हैं. एज एन एग्जांपल, इफ यू हैव अ सिस्टम इन विच द सिस्टम इज नॉन रिपेयरेबल, तो यू वुड से you can quantify the reliability of this system by mean time to failure. और if your system is repairable, जिसमें अगर सिस्टम ख़राब हो जाए तो उसको हम कुछ टाइम उसको रिपेयर करके वापस उसको सर्विस में ला सकते हैं. You can quantify the reliability of this system by mean time between failures. So mean time between failures के साथ एक और टाइम बेस्ड मेट्रिक भी है जिसको हम मीन टाइम टू रिपेयर कहते हैं, which is if a system goes down, what is the average time it takes to repair the system and get it back up. So these are all examples of time based metrics. So let us now talk about rate based metrics. हम पहले देख चुके हैं कि तीन fundamental metric types हैं. The first one was time based metrics, the second one was count based metrics or number based metrics, and the third one was rate based metrics. Rate based metrics में हम किसी entity के count या किसी parameter के size को normalize करते हैं against unit time. So let me give you some examples of rate based metrics. An example can be throughput, and throughput can be in jobs per second or request per second, or million instructions per second, millions of floating point operations per second, packets per second, bits per second, transactions per second. These are all examples of throughput. जिसका मतलब है कि how many of certain operations are you doing in unit time. So these are all examples of rate based metrics. इसके अलावा जैसे हमने शुरू में बात की थी कि फंडामेंटल जो मेट्रिक टाइप्स हैं उनको हम कंबाइन भी कर सकते हैं टू फॉर्म न्यू परफॉर्मेंस मेट्रिक्स, और उसमें जो एक प्राइम एग्जांपल है वो है रेशो बेस्ड मेट्रिक्स, जिसमें हम ये जो फंडामेंटल मेट्रिक टाइप्स हैं उनमें किसी का रेशो लेते हैं. सो लेट्स सी एग्जांपल्स ऑफ दीज देन. अ फर्स्ट एग्जांपल इज यूटिलाइजेशन, और यूटिलाइजेशन को हम डिफाइन करते हैं एज द रेशो बिटवीन बिजी टाइम एंड टोटल टाइम. सो इट्स अ रेशो बिटवीन टू टाइम इंटरवल्स. बिजी टाइम का मतलब है कितनी देर सिस्टम बिजी है, और टोटल टाइम आपका टोटल ऑब्जर्वेशन टाइम है. If we take a ratio of this, this gives us the utilization of the system. As we can see in this slide, kuch time system busy hai, and that is shown in the darker color, and the remaining time the system is idle, and that is shown in the lighter color. Utilization would be busy time divided by total time. So if your busy time is too much, you would have a high utilization. On the other hand, if your busy time is less, you would have low utilization. Another example of a ratio-based metric is availability. And we often we can have different definitions of availability, and we're going to give you two definitions. The first definition is the ratio between uptime and downtime. If you observe closely, this is again a ratio between two time intervals. Uptime का मतलब है कितनी देर डिवाइस अवेलेबल है सर्विस के लिए, और डाउन टाइम का मतलब है कितनी देर सिस्टम जो है अनअवेलेबल रहा. सो इफ वी टेक अ रेशियो ऑफ दिस, इनफैक्ट हम रेशियो इस तरह लेते हैं कि वी डिवाइड द अप टाइम बाय अप टाइम प्लस डाउन टाइम विच इज द टोटल टाइम. तो उससे हम देख सकते हैं कि सिस्टम कितनी देर अवेलेबल रहा. सो इफ वी कैन एक्चुअली मिनिमाइज द डाउन टाइम, you would see that the availability increases. So it's very important. Availability के बारे में जब हम बात करते हैं, so I'll give you some stats here. कि 99.9% availability का क्या मतलब है? How much of downtime can you actually tolerate if you want to have 99.9% availability? So it comes out to 9 hours downtime per year. And if you increase 99.9 to a more precise value of 99.99 or a more stringent value, you would see that the amount of downtime that you can have is drastically reduced to just approximately 1 hour. And if you make this requirement even more stringent, you would see that with the requirement to have 99.9999% availability, you can only have 32 seconds of downtime per year. So no wonder service providers call this the tyranny of nines, because एक 9 बढ़ाने से you can observe कि कितना कम downtime हो जाता है. There's another way of measuring availability, and it's as a ratio of mean time between failure to mean time between failure and mean time to repair. So we see that the total time is actually equivalent to the sum of mean time between failure and mean time to repair, जिसमें दोनों के मतलब भी इंट्यूटिवली समझ आते हैं. मीन टाइम बिटवीन फेलियर का मतलब है कि सक्सेसिव फेलियर्स के बीच में आमतौर पे कितना टाइम लगता है, और मीन टाइम टू रिपेयर का मतलब है कि आमतौर पे जब सिस्टम फेल कर जाए तो उसको वापस एक्टिव करने के लिए कितना टाइम लगता है. तो अवेलेबिलिटी को हम डिफाइन कर सकते हैं एज अ रेशो, एंड दैट रेशो वुड बी बिटवीन, यू वुड हैव इन द न्यूमरेटर मीन टाइम बिटवीन फेलियर, and in the denominator you would have mean time between failure plus mean time to repair. और जिस तरह हमने पहले देखा था कि availability को आपने improve करना हो तो आपको down time को reduce करना चाहिए. इस केस में अगर आपने availability को improve करना है तो आप mean time to repair को reduce करेंगे. If we can reduce mean time to repair ideally speaking to 0, तो आपकी availability 1 हो जाएगी, because whenever the system has a fault it can be instantly rectified. लेकिन obviously realistically this will always be non-zero, but we would like it to be a very small value so that we have high availability. इसके अलावा what other ratio based metrics can we think of? We also have another important consideration. Whenever you have a shared resource, you also want to see that no one user is monopolizing the available resource. ऐसा नहीं होना चाहिए कि एक यूजर majority of the bandwidth for example ले ले और बाकी सारे users को एक तरह से starve कर दिया गया है. So how can we measure fairness? So there are various measures for fairness. I'm going to talk about just one. So it is shown on the slide, and this is known as Jan's Fairness Index. And what is this trying to measure? This Jan's Fairness Index is actually going to give you a number between 0 and 1. और अगर आपकी fairness index अगर 1 के करीब उसकी वैल्यू है, इसका मतलब है कि आपका सिस्टम टोटली फेयर है और जो आपकी शेयर्ड रिसोर्स है उसका इक्वल शेयर सबको मिल रहा है. बट इफ your value of fairness index is closer to 0, that means you actually have a starvation problem. One user or some subset of all users are getting a majority of the share of the resource while others are starving. तो इसका हम formula देखते हैं. So if you observe, you would see that the numerator and the denominator is similar looking, but there's a subtle difference. In the numerator, you have a square of sum, and in the denominator, you have sum of squares. And in fact, if you calculate this, or let me explain कि xi का क्या मतलब है यहाँ. xi का मतलब है कि user I को कितना resource का share मिल रहा है, और all in all, you have n contending users. तो इसके हिसाब से हम ये fairness index calculate करते हैं. And if you have a value closer to 1, that tells you that your system is performing well in a way which is fair to all users. But if your fairness index is closer to 0, that tells you there is a problem of unfairness in your system. Let me now recap our discussion and tell you what are important considerations when we're thinking of performance metrics. तो जब भी आप कोई परफॉर्मेंस स्टडी करते हैं, किसी नेटवर्किंग सिस्टम को आपने एनालाइज करना है, you have to think of all the performance metrics which are relevant. जिस तरह हमने शुरू में बात की थी कि a system may be sent a request, the request may be done or it may not be done. If it is done, it may be done correctly or incorrectly. So this discussion was for a single service, but your system might be doing different kinds of service. So for all those services, you have to think कि क्या क्या ऐसे measures हैं जो we must quantify, because it may be that your system performs well in 90% of the performance metrics, but it does not perform on a very critical performance metric. तो अगर हम सिर्फ एक subset के अंदर analysis करें और उसके अंदर वो critical performance metric नहीं है, तो we might conclude that this system is very good, but this may not be the case, because that critical system performance metric, उसमें जो हमारी performance खराब है, उसकी वजह से our system may actually be totally unusable for practical purposes. So performance metrics जब हम decide करते हैं तो क्या क्या consideration है? Let me just describe that very briefly. तो एक तो ये है कि we must describe both performance time, performance rate and resource. We can also discuss, and we should also discuss, reliability measures and availability measures. उसके अलावा an important thing is कि हम सिर्फ metrics की बात कर रहे हैं, but we have to measure them giving us a data set, and then we have to see कि उसको हमने कैसे इस्तेमाल करना है. For example, how do we gain insight from this? How do we develop meaning from all of this data? तो एक उसका हल ये है कि we take average values, but taking just average values is not always advisable, क्योंकि a benefit of taking average values is that it gives you a single number, but that single number may not be very useful if you have a lot of variation in your data. So you must always consider that you should always consider doing a study of how the system is having, what kind of variance it is having. So if it is having a large variance, you should not only depend on the average value, but you should also quantify the variance. And also an important thing is that when we are considering metrics, we should optimize both for the individual users and systems and also for the global users and systems. And they are not synonymous, because they do not mean the same thing. The reason is because it may be that if you're optimizing for a single individual, the global performance may actually degrade. And this is an important concern. So we have to, for example, consider fairness, and we also have to see how do we quantify the performance of the system as a whole and of the particular users. इसके अलावा, when we are considering adoption of performance metrics, some desirable features are that it should have low variation. It should also be non-redundant. यानी कि दो metrics अगर आपको similar information दे रहे हैं, तो it's better to use a single metric and not two. So if you have redundant metrics, try combining them into a single one or just using one. Lastly, completeness is important. As mentioned earlier, critical performance metric को अगर आप छोड़ दें तो आपकी performance evaluation may be actually invalid. So it's important that we analyze all the relevant performance metrics and not just those metrics which makes us look good. So I'll conclude with two remarks. The first one is we should always choose the performance technique that we use according to the goal of our network performance evaluation study. And the second one is that whenever we're doing network performance evaluation, it's important that we take care about all the metrics that are relevant. So we must have completeness. So this closes the session today. I will see you inshallah next time. Assalamu alaikum.